And good Wednesday morning as we are halfway through week 7 with only 1 week to go. And as promised, I'm going to go through the exercise problems from the module in order to understand these and be able to complete the homework assignment questions. So on your screen you can see reservation and overbooking example, which is very interesting because this method of net factored risk has a lot of applications in industry and services and also in manufacturing. So once I go through the example, I'll also explain how it's applied in other areas of program management. So in this example, a family-run inn is trying to decide the cost trade between overbooking and underutilizing rooms. And as you can see here, an empty room is an opportunity cost of $69 of what they charge per night. And if the room is empty, they lose that opportunity to make $69. And of course, if they overbook and they have to send customers elsewhere, they pay the difference between the $119 at another hotel and the $69 at their hotel. So it becomes a $50 loss essentially, because they are collecting the $69 but then sending them somewhere else and paying the extra $50 for the $119. So their data for a given night shows that the frequency of 0 no-shows is 4 in a given night. The occurrence of 1 no-show is 3 for a given night, and no-shows 2 is frequency of 2, and no-shows of 3 is a frequency of 1. This happens to total 10, but it doesn't necessarily need to total 10. It just makes the math easier in the example. It could be 10 no-shows of 0 could be 10 occurrences. You just need to do this as a percentage. So let's go down to the solution. So what they did was create a matrix of no-shows versus overbooking. So 0, 1, 2, and 3 no-shows. And the reason I said that about just happening to equal 10 is because the probability came out to 0.4, 0.3, 0.2, and 0.1, which equals 1.0. But if this was 5, then that would have been, instead of 4 out of 10, that would have been 5 out of 11. So either way, you can divide the frequency by the total and get the probability. And this is real important for net factored calculations, to use a probability. So then on the overbooking side, if you have 0 overbookings, that means you have to accommodate every person that shows up, and you have 0 no-shows. You did well. You used every room that you had. But now if you have 1 no-show, you have an opportunity cost of 69 times 1, 69 times 2, and 69 times 3, because now you have empty rooms. If you overbook 1 room and you have 0 no-shows, that person has to be sent to a different hotel. So that's a $50 loss for 1 person. 1 overbooking and 1 no-show, you break even, everybody's happy. 1 overbooking and 2 no-shows means you have 1 empty room. 1 overbooking and 3 no-shows means you have 2 empty rooms. So 69 times 1, 69 times 2. And you can do the math all the way down here, where if you went to an extreme and you overbooked 3 rooms, you had 0 no-shows, you're losing $50 times 3 because you have to send all 3 people to a different hotel. If you have 1 no-show, you have to send 2 to another hotel. If you have 2 no-shows, you have to send 1, and then 3 overbooks and 3 no-shows is a break-even because you have 3 available rooms for 3 overbookings. So now the important part: how do you calculate the probabilistic loss of money as a result of these numbers and these probabilities. And what you do is you go into each column and you say the probability of zero cost. This is all loss factors, either opportunity lost or sending them to another hotel loss. So the probability 40% of zero, and then there's a 30% probability of losing $69, a 20% probability of losing $138, and a 10% probability of losing $207. So you take each of these numbers, multiply it times its respective probability, and add it up, and your expected total loss is $69 if you overbook 0 rooms and just basically lose the benefit of empty rooms, or lose the cost of empty rooms. Same thing here. You take 50 times 0.4, 0 times 0.3, 69 times 0.2, 138 times 0.1, and you get a net factored loss of $47.60. Then you go over here to the extreme 3, and you multiply times each probability, and you get a net factored probabilistic loss of $100. Now, getting to the answer before I apply this to other applications, you can see that the sweet spot for the lowest probable loss is 47.60. So if you're this innkeeper, manager, owner, you would say that your best probabilistic situation is to overbook 1 room with the probability of losing $47.60. Now what's interesting in industry, like in the defense industry, we have management reserve money that we hold off to the side that is not allocated to any projects, tasks from an earned value management system, EVMS, if you've ever heard of it. But in simple terms, you've allocated every dollar of your budget, but you know things are going to happen. And those are called risks. And in the risk management area, you want to make sure your management reserve holds all the risk money that it needs. Now, if you have 10 risks with a cost per risk of $100,000, you would think, okay, worst case is I'm going to need $1 million to cover those 10 risks at $100,000 each. But that, if you think about it, would only be if every risk becomes an actual. So every risk comes to fruition, you're going to pay $100,000 to fund that task that you didn't expect. But that's not usually the case. There are probabilities that some will happen and some will not. So what you do is you go down the line here and you put the 100K for risk 1, 100K for risk 2, 100K for risk 3, 100K for risk 4, and what's the probability of that risk occurring? And say it's the same thing here, points 40, 30, 20, 10. It doesn't have to total 1.0 because risks can all occur. So you could have a 1.0 that, or I wouldn't put a 1.0 because that means you know it's going to occur, so you're going to fund it. But say a 0.8, a 0.7, a 0.8, a 0.3, and then you multiply those out times the 100K and you add it up, and the net factored risk becomes the amount of money that you need to keep in your management reserve. So this method of overbooking analysis really is exactly the same as risk management and net factored risk for management reserve purposes. So it's a very interesting probabilistic calculation, and since it is a probability, you could go over or under based on more problems than expected happening, or basically more no-shows than expected happening on any given night. So it is only a probability based on statistical data. Thank you, and I will now go to the next exercise. Okay, now that I'm done going off on that tangent of risk management and net factor risk, we will go to problem 11.6. reservation and overbooking example. This is actually not a reservation overbooking example. This is the how many nurses you would schedule each day of a week in order to coverage the demand. So this is more of a demand scheduling example. So problem 11.6. The hospital data shows that this is how many nurses are needed to cover each day of the week based on statistical demand. And I keep on using the word statistical because one thing you're going to notice is that all these decisions need to be data-driven. Earlier in the course, we talked about the more subjective, qualitative analysis and the intangibles, kind of the touchy-feely, softer side of management and customer satisfaction. Now when it comes to running a business with skilled labor, and you can't just plug anybody in to do any of the work, you have to be more prudent about scheduling who's working on which days, and you don't want people sitting around unused because you are wasting money, and you don't want too few people because then you have a serious customer satisfaction and you're simply not getting the work done. So with that being said, their data shows that they need this number of nurses on each day based on their typical demand, keeping in mind that Saturday wraps around to Sunday. So if it said Sunday, it would be back to 3 again on here. So we are to develop a work shift schedule to figure out how to staff this with a maximum of, I believe it said 8 nurses. So we come down here, and it shows again what's required with this being wrapped around. And what we do is we take the pairs of days that have the lowest total. So here you have Sunday, Monday 9, Monday, Tuesday 11, Tuesday, Wednesday 11, Wednesday, Thursday 12, Thursday, Friday 12, Saturday, Sunday 8. So we take the first nurse and we schedule her with the days off being the least number of nurses needed, which is 5 and 3 is 8. So we schedule her here with Sunday and Saturday off. Of course, this is repetitive, so Sunday comes next. She actually has Saturday and Sunday off. She's lucky she gets the weekend off. Then we come down here and we do the subtraction and say, okay, now how many are still required each day after nurse 1 works Monday through Friday? And again, we go to the smallest pairs, and it is 8, 9, 9, 10, 10, and again 5 and 3 makes 8. So nurse 2 is lucky and gets the weekend off, and we subtract that from the number of nurses needed. So we originally needed 6, we used 2, 4 are still required, so on down the columns. So we keep on doing that over and over again until we get to nurse 3, and she had Sunday and Monday off because there was a 7, a 7, a 7, an 8, an 8, and an 8. So you could arbitrarily choose whichever of the 7s was the lowest number. So this resulted in getting Sunday and Monday off for this first pair of 7. So we keep on going down the line until nurse 5, and then nurse 6 and nurse 7, and by the time you get to nurse 8, you have 0 required. So you met the requirements for 2 days off per week consecutive with a maximum number of 8 nurses on the job to fill the demand that the data showed was needed. And here is the weekly schedule as a result, where they just changed their 0s and 1s to off and X. So that worked out very nicely. So if you have any questions on either of these 2 examples, please email, call me, text me, whatever you want to do. Post a discussion posting in the general area so that we can all see it. but also make sure you subscribe to the general discussion so that when things get posted, you will be notified of them. And otherwise, have a great week 7, and let's stay in touch. Thanks, class. I appreciate it.